Find an equation of a rational function f that satisfies the given conditions. We have vertical asymptotes at x equal -3 and x equal 1. Horizontal asymptote is y equals 0. An x-intercept at -1, 0. The y-intercept f of 0 is -2, and there's a hole at x equal 2. Let me pop up a graph of these conditions so we can see them visually. Okay, here we are. We see the two vertical asymptotes, the horizontal asymptote on the x-axis, and the hole somewhere at 2. We don't know quite where that is in terms of the y value, so I just left that marked on the x-axis. Now, we have a rational function, it says. So a rational function is a ratio of two polynomials. So we're going to have a numerator and denominator in our function. And let's start filling in some of the pieces that we know. Vertical asymptotes produce or come from zeros in the denominator only. So we must have an x plus 3 factor and an x minus 1 factor to produce the two vertical asymptotes. We also have a hole. We've got the vertical asymptotes checked off. Let's check off this hole. A hole will occur where the denominator and numerator are both 0. So x minus 2 must be a factor in the denominator so that x equal 2 is restricted from the domain, but x minus 2 must appear in the numerator as well so that we don't get a vertical asymptote but merely a hole. To find the horizontal asymptote, we can look at the ratio of the highest powers of x. We'll do that after we've filled in the x and y intercepts and made sure we've got those correct, and then verify the horizontal asymptote is okay as well. The x-intercept is -1 for x and 0 for y, so we need to have a 0 for the function where x is -1, and we can see how to do that by just doing x plus 1, so that when we put in -1 for x, this factor is 0, which will make the whole rational function 0 there. Now so far we have, if we multiply this out, we will have an x squared plus some smaller terms in the numerator. We'll have an x cubed plus some smaller terms in the denominator, and because the degree of the denominator is higher than that of the numerator, we will have y equals 0 as a horizontal asymptote as is indicated. So we're all set for the horizontal asymptote at this point. Let's check this condition, the f of 0 equal -2, and see if we've got that right, or if we need to make any adjustments. F of 0 is 1 times -2 divided by 3 times -1 times -2, and just plugging in 0 for x there and seeing what that simplifies to. And when I simplify, I actually don't get -2. I get 1 over -3. Well, how are we going to get -2? Notice if we were to multiply this by a 6, that would give us the -2. Okay, so that's an adjustment I can make. If I put the multiplication by 6 here, then I needed it here, and I needed it here. And of course that would produce it over here as well. So it looks like the change I need to make to get the right y-intercept is to multiply by this 6 in the numerator of my function f. That will not affect any of the work we've done before. In particular, the horizontal asymptote will still be at y equals 0, because regardless of what the coefficients are, the degree of the x cubed is higher than the degree of the x squared, and so it we will get a y equals 0 for our horizontal asymptote. All of the rest of the pieces will stay as we had already described them, and so that is the expression for the rational function f that was requested.